Hello everyone. Today we are going to start new series about neural networks. And the first topic in our first topic I want to talk about uh, perceptron. So what is a perceptron? Perceptron is one of the simplest artificial neural network architecture, and it has been invented in 1957 by Frank Rosenblatt. It is based on a slightly different artificial neuron, and we are using a threshold logic unit, or sometimes linear threshold unit. The inputs or outputs are numbers instead of binary values. And each connection is associated with a weight, each input connection. And the step function, the TLU first computes a linear function, and then it applies a step function to the result. Sorry, the threshold logic unit, it computes the linear combination of our features and the inputs. Then we applied a step function. And step function is a very simple function that we're talking about here. So we will give you an example, a very simple example, very simple linear classifier we're going to talk about. And let's say we are going to classify points based on inputs and weights. So Perceptron takes an input vector, um, which are basically the features. These are our basically features. For example, we want to classify whether this person is obese or not, and these can be the weight of the person, the age of the person, or some other biological symptoms that we can add to our features, and etc. And then we will compute a linear combination of these features um, and weights. So we also have weights. These are basically the parameters of our perceptron: V1, V2, and Vn. And the weighted sum will look like this. And etc. And we have a step function that returns 1 if z is bigger or equal to 0, and it returns 0 otherwise if z is less than 0. So this is basically a binary classifier that we are trying to make, which says, based on the features, whether this person is obese or not. And I'm going to draw the diagram, the neural network, the perceptron that only has one neuron. So we have x1, the associated weight, we have x2, and let's say we have x3. Let's say we only have 3 features that will decide whether this person is obese or not. So V2 and V3. And here in this neuron, firstly, we calculate the sum. Let's just, separate them. So, okay, let's say we are calculating the sum here, and then we have a bias. This is another parameter because this is a linear classifier, and a linear function also has a parameter called b, and with b we are um, basically adjusting how hyperplane, where the hyperplane or the line will intercept the y axis. In terms of a simple line, it will be y-axis, um, but in higher dimensions, we will talk about hyperplane cutting through the y-axis. So this is how we adjust that line or a hyperplane if we have more features. And then we have a step function. And then the step function will output. And of course, we also have the labels because this is supervised learning. And let's say 1, y2, y3, and etc. And let's say how this will work. Let's say we have 3 features and we have 3 training sample. And we're going to train our perceptron. Y1, Y2, and Y3 are the associated labels with those samples. So what happens here is that first we initialize our parameters. Well, here I will not go into detail of how we choose the parameters, but we're going to discuss it in our next videos. And let's say we choose random values for our parameters. V1, W2, and W3, the weights and the intercept B. And let's say we calculate our weighted sum. Plus B. All of them are just some numbers. And then we apply the step function. Let's say this weighted sum will give us minus 0.5. And then we take this and give it to our step function. And if we go back to the step function, we see that if it's less than 0, we're going to output 0. So our prediction for sample 1 is 0. And let's go back and see the true label. Let's say the true label was actually 1, but we took 0, right? Now we calculate the error. Which is what? Which is 1. Now we calculated the error. We're going to update our weights. And how will we update it? I'm writing them. For example, let's say we are updating W1. So the new W1 will be W1 W1 plus W1 yeah, W1 plus the error multiplied by the associated feature, which is x1, plus, oh sorry, not plus, multiplied by the learning rate alpha, let's say. And the others the same. And let's analyze these update rules. So firstly, this error is 1. And it's obvious that the value of V1 should increase, right? Or should increase more than if it error was let's say 0 or -1. So the thing is, right now our prediction for the first sample was we under predicted because it should have been 1, but we predicted 0. And intuitively, this z should have been more, should be close to, should be bigger than this in order to have the correct step function, because if it was, for example, bigger than 0, then it would produce 1, right? Then we would get the correct prediction. So that's why we are increasing the number of, increasing the value of our weights. So that's why the error plays an important role here in which direction we are going. Are we decreasing our weights or are we increasing our weights? And also, we have to scale it by the feature. Why do we have to do it? Because each weight has a different say in our prediction. For example, if we had x1 bigger than x2 and x2 bigger than x3, it means that even a small change to v1, w1, will have a more effect than the others because it's associated with a bigger feature. So it will affect our weighted sum more. So if this weighted sum was underestimating, it should have been more, not not negative 0.5. Then it means that the feature that we are going to blame the most is this one, right? And then we should, if this is the one that we are going to blame the most, then we also have to increase the amount associated with weight and feature more. So that's why we are multiplying it by x1, because if we don't have x1 here, it means that every weight has the same effect in our weighted sum. Then it wouldn't make sense because we have to blame this one the most because it has the biggest effect in our weighted sum. That's why we also have to adjust this parameter the most. So that's why we multiplied it x1. And what is lambda? Lambda is just another term that we add in order to control how fast or how slow we are going to update our weights. And with the same logic, we are going to update V3 and B. Error just and multiplied by a lambda. So now we have updated our parameters. Then we go to the second training sample And using these parameters, we make a prediction. Then we keep repeating the same process, and eventually we end up with the optimized parameters for our classification problem.